Hi all, let's start first session of chapter electrostatics, and the main topic of this chapter it will be electric charge. And I hope all of you you're familiar with electric charge. So most of you, I think you have covered this topic in 10th standard. But in 10th standard, we have covered the very basic definition and the meaning of electric charge. Okay, so basically we already know there are two types of charges. Okay, so first is positive charge, negative charge. Okay, so let's start with the first session. So basically this topic electric charge, it will be backbone of this chapter electrostatics. Okay, so now you will get to know the deep knowledge about electric charge. Okay, yeah, let's start. So basically we already know we have done a couple of experiments directly or indirectly. Many times you have felt that when you try to comb your hair, so you can hear some kind of uh, you can say chit chit sound. Okay, so very little sound, or I think in your you can say earlier days. So when you will place couple of paper pieces and you will try to attract those pieces with comb. So many times it attract. Okay, so many times when you stand up while sitting on a plastic chair, so you heard some kind of noises. So all these noises because of electric charge. Okay, so let me give one example. So basically in this example, so there is a balloon. Okay, so and it's tap from water is coming. Okay, so when you will take this balloon near to this tap of water, so the flow of water, it will be attracted towards this balloon. Okay, so all this because of electric charge only. Okay, so these are the examples. So basically, and yeah, this experiment, I think all of you, you have done this experiment directly or indirectly. Okay, but the question is, I think in your childhood days, so I think you were amazed why all these you can say very light things they are attracted towards your hand. Okay, so because of charge only. So basically, charge, these are present everywhere. Okay, so there is a condition. Basically, mass it can exist without charge. Okay, but charge it can't exist without mass. So charge always be associated with mass, always. Okay, so basically charge it can't exist without mass, but mass it can exist without charge. So basically we can say we are surrounded by charges. We are surrounded by charges. Clear? Any doubt, any confusion so far? Okay. So first 2 to 3 lectures, so you will get basic knowledge about electric charges and the backbone of this chapter electrostatics. But after 2 to 3 lectures, you will dive into the sea of electrostatics. Okay. So what is charge? So what is charge? Charge basically it's a property of matter. Okay. So it's property of matter. So because of this property of matter, so many times we can feel a charge, a force of attraction. Force of attraction. For example, I will give a couple of examples. Okay, so when you will rub an ebonite rod, or you can say glass rod with a fur or with a silk cloth. Okay, so charge is induced on that rod. Why that charge is induced? What is the function or what is the concept behind those induction of charges? So we will talk about it later. Okay, so there is a property of charge that is wait, just give me a second. Yeah. So basically, if there is any charge, let me give an example. For example, if there is a charge, okay, so because of presence of this charge, so there will be an electric field. There will be an electric field around this charge. Okay, and how we can say there is an electric field around this electric charge because of it is based on a number of experiments we have done. I think most of you know about a property of charges, that is, like charge, they will repel each other, and unlike charge, they will attract each other. So that property of charges is because of this electric field. So we will talk about it later very deeply. Okay, don't worry. Clear? Now, so there is another experiment, or we can say there is another observation. So when an electric charge is placed inside in an electric field, magnetic field, so a force on that electric charge will be experienced. So these are some random properties. So we will talk about these properties one by one. Okay, clear? So far we discussed that charge, it can't exist without mass, but mass, it can exist without charge. Clear? Okay. So, and guys, keep preparing your notes, because notes, these are very, very important. Okay, so who have entered in 12th standard right now, so initially you will feel like yeah, syllabus is okay, but after some time you got to know. So when you will cover a considerable syllabus, so you will forget the chapter names. So the syllabus for 11th and 12th standard, it's very, very huge as compared to 9th and 10th standard. Okay, yeah. So now, next property of electric charge, that is, charge in motion, they will produce electric and magnetic field. Electric and magnetic. Okay. So basically, yeah. So when a charge is at rest, we can say, let's suppose it's a charge, it's a positive charge. Okay. So whenever, now there is thumb rule. So now onwards, when you will consider any electric charge, so always consider a positive charge. Okay. So don't confuse your mind that one time you will consider negative charge, second time you will consider positive charge. No. So every time if we have to assume any charge, just assume positive charge. Okay. So now, if a positive charge is at rest, so because of this positive charge, there is electric field around it. I have already shown you like this. Yeah. So you can see these are electric field lines. Don't worry, we will talk about it later. I'm just drawing randomly. Now, if that electric charge, if it is in motion, if that electric charge, so in electrostatics, we represent electric charge by Q. Okay, now if this charge, if it is in motion, then it will produce magnetic field also. Velocity, okay. So it will produce magnetic field also. Magnetic field. Clear? Okay, so it's a second property of electric charge. Right here. Okay, it's second property. So first property, it was first in this one. So when a charge, if it is at rest, then it will produce electric effect. Electric. These are very, very important topics. Because after this chapter electrostatics, so we will cover second chapter electricity. Then we will cover magnetic field. Okay. So right now we are just saying that first when the charge when the charge it is at rest, so it will produce electric field. When it will move, then it will produce electric field plus magnetic field. So we are saying very casually, but later you will get to know it's a huge level. It's a big chapter, magnetic field. Okay. Now let's talk about third point. Okay. Now if a charge Q, if it is moving, okay, but with acceleration, with some kind of acceleration, then it will produce electric field plus magnetic field, and it will radiate energy also. It will radiate. It's a third property of electric charge. Keep note down. Okay, keep noting down all the points. Okay, so these are the first three properties of electric charge. These are very basic properties. Okay, apart from those properties that like charge they will like charge they will repel each other, unlike charge they will attract each other. Okay. Now let's try one question. So question is, let's see who remembered all the points. So first question is stationary electric charge produces option A, option B, option C, and option. Let's try this question. I'm giving only 5 seconds. Oh, yeah. Now let's try this question. So basically, the first property of electric charge, that is, when a charge it is at rest, it will produce electric field only. Answer is A. That was the first property of electric charge. Now, if we talk about second question, yeah. So when an electric charge, so it is moving with basically it's moving with some kind of velocity, okay, constant velocity, uniform motion, okay, and option A, okay, let me write option again. Option A, B, C, and D. Let's start this question. I'm giving 5 seconds. Why I'm giving 5 seconds? Because these questions are very basic questions. So basically these are based on memory. Yeah. So basically we already know when an electric charge it is in a uniform motion, it will produce both electric and magnetic fields. Both electric and magnetic. Clear? Now, is there any doubt, any confusion? Now, let's try next question. So again, this question is again based on memory. Yeah, question is an accelerated or deaccelerated charge produces option A, B, C, and D. Let's try this question. I think most of you remember third property of electric charge. That is, when an electric charge, if it's moving with an acceleration or deacceleration, then it will produce electric field, magnetic field, and it will radiate energy also. It will radiate energy also. So these are the very fundamental or very basic questions. Clear? Now let's move forward. So far, is there any doubt, any confusion? Oh, yeah. So now, so we can summarize all these 3 points in pictorial method. So basically, first, when charge is at rest, that is velocity is 0. Let me, yeah. So these are the 3 points. Yeah. So first one is when a charge is at rest, then it will produce only electric field. Okay. So yeah. So we always represent electric field by this E vector sign. Okay. Now, if an electric charge it is moving with constant velocity, it will produce electric field and magnetic field, but no radiation. Now, in case when velocity is not constant, either it's increasing or it's decreasing. In that case, it will produce electric field, magnetic field, and it will radiate energy also. Clear? Any doubt? Any confusion so far? Okay. So now let's move further. So you can note down this point. Just once again. Clear? Okay. Yeah. Now, basically, SI unit of electric charge, it's coulomb. It's coulomb. Okay. So now, yeah. So its unit is coulomb. So we represent by C. Okay. But then you can see the notation we use for electric charge, either it's capital Q or small q. And it's my humble request, please don't create your personal notation for this. If you can create, you have to handle also. Okay. Now, first point is as a unit of electric charge is coulomb. Second point is dimensional formula. Okay. Now, if you remember, formula for electric current, it's rate of flow of electric charge. Okay. So from here, we can derive its dimensional formula. So we can write this as delta Q, which is equal to I into delta T. So Q, it will be equal to I. So dimension for current is ampere into time. Okay, so this is the dimension formula, and it's a scalar quantity. Charge, it's a scalar quantity. So what does it mean? It means if you charge Q, if it's moving in this direction, or in this direction, so its properties will be same. Okay, so there will be no effect on its properties in different directions. So we can add the charges directly, algebraically. Okay, and what are the examples of electric charge? So proton, electron, neutrons are not example of electric charge. Protons, alpha particle, electrons. So these are the charge of. So these are the example of electric charge. Here, any doubt, any confusion? You can note down these points. Clear? Okay. Now let's topic. Yeah. So if you talk about the basic unit of electric charge, that is charge of electron, one electron, single electron. Okay. So if you talk about the smallest quantity of charge that exists in our nature, that is charge of electron. And what is charge of electron? That is, you can see here, 1.6 into 10 to the minus 19 coulomb. So charge of electron is minus 1.6 into 10 to the minus 19 coulomb, and charge of proton is 1.6 into 10 to the minus 19 coulomb, and charge of neutron is 0. Okay, and how we assign the charges? So I think it doesn't matter. So basically, there was a scientist named Benjamin Franklin. So he assigned this positive and negative sign. Okay, so after that, so we are considering all the protons, they are carrying positive charge, and neutrons they are and electrons they are carrying negative charge. Clear? You can note down these points. So far, is there any doubt, any confusion? Okay. So so far we discussed about three properties of electric charge. Okay. So then we discussed about some points, important points regarding fundamental charge. Now let's talk about type of charges, and we already know. I think everybody knows about the types of charges. So is there anybody who is confused about types of charges? So basically, there are two types of charges. First is positive charge. What does it mean? It means it has deficiency of electrons. Deficiency of electrons. And what about negative charges? So those charges, basically those objects which are having extra electrons. Let me give one example. if you talk about chlorine, okay. So everybody knows about electronic configuration of chlorine. So if it will acquire one extra electron, then it will acquire its stable configuration. Okay. So because of this extra, actually in nature, actually chlorine doesn't have that extra electron, but there is a tendency of the chlorine element, or you can say atom. So there is a tendency to acquire extra electron to get the stable configuration. So when it will acquire this extra electron, so if chlorine has number of proton 17, now it will have 17 plus 1 extra electron, 18 electrons. 18 electrons. So now you can see there is unbalancing of charge. So when it will acquire extra electron, so it will be represented like this, Cl negative. It's having extra electron. So because of this extra electron, it will acquire negative charge. Okay, so these are very basic fundamental points I'm dictating. So what is positive charge? Okay, and what is the sign of positive charge? So it is the deficiency of electrons as compared to proton. Simple definition. Now, if we talk about negative charge, it is the excess of electrons as compared to proton. Okay. Now, let's suppose you can see here there are 1, 2, 3, 4, 5 positive charges and 5 negative charges. Now, let's suppose if I am so let's suppose we have removed 2 electrons. So now it will have +2 polarity. +2 means it has lost 2 electrons. Clear? Any doubt, any confusion? Now let's move forward. So you can note down these points. Okay. So now let's try a couple of questions based on this concept. So first question is, if an object has a net charge of -1 coulomb, then number of excess electrons it possesses is option A, option B, C, and D. Let's try this question. So let me give one hint also. Hint is, so there is a property of electric charge, that is, charge is quantized. Charge is quantized. What does it mean? It means in our universe, so charge exists in the integral multiple of unit charge, that is charge of electron. For example, charge, we already know charge of 1 electron is 1.6 into 10⁻⁻19 coulomb. So it's the basic unit of electric charge. Okay, so charge can't exist like this, 0.5 E. Okay, so it can exist like 1 E, 3 E, 4 E, means integral multiple of electric charge. So this property of electric charge is called charge is quantized. Okay, so there is a basic, there are some packets. Okay, for example, charge exists in the integral multiple of charge of 1 electron. So this is the hint. Now you can try this question. So basically, let me solve first question. So we can say the total charge will be n times E. Clear? Now we can see an object, it's carrying how much? It's carrying -1 E. So we can say total charge is -1 coulomb. Sorry, -1 coulomb. Okay, it will be n times charge of 1 electron. That is -1.6 into 10⁻⁻90. Okay, so n will be 1 divided by 1.6 into 10⁻⁻90. So answer will be B. Answer is B. Answer will be B. Okay. Now, so this time you have to solve this question. So next question is, if your body has a charge of 10 raised to power minus 12 coulomb, option A, B, C, and D. Option A, the body has 6.25 into 10 raised to power 6 excess of electrons. The body has 6.25 into 10 raised to power 6 excess of electrons. And option C, the body has 6.25 into 10 raised to power 6 deficiency of electrons. And option D, the body has 6.25 into 10 raised to power 3 deficiency of electrons. So let me repeat the question again. If your body has a charge of 10 raised to power minus 12 coulomb, so we can see its charge, it's positive. If it's positive, for example, there is an object like this, okay, and it has charge of 10 raised to power minus 12 coulomb, and it's positive. It means it has lost its electrons. Now, if it has lost its electrons, so we can remove first two options directly. Okay, so now we can use that property of again, that is charge is quantized. So total charge is how much? 10 raised to power minus 12, and times charge of 1 electron, that is minus 1.6 into 10 raised to power minus 19. Minus 19. Okay, so now the value of n, it will be 10 raised to power minus 12 minus divided by 1.6 into 10 raised to power minus 19. So when you solve, I think answer of this question is C. Okay, so this negative sign, it's showing that number of electrons has been lost by this body. Clear? Any doubt? Any confusion? So you can note down this question.
When you strive for excellence, you can't settle for mediocrity. So to succeed in any competitive exams, you need to have an expert mentor, best designed syllabus, test materials, and someone who cares for your career just like you. Welcome to Regis, where our programs are designed and executed by the IITians. Enroll your board now, because we believe in nothing but the best.